Standard 7th, Subject Geography. Today, let us learn Chapter 5 Winds. Dear students, we feel the wind but cannot see it. When certain objects in our surroundings move, we experience wind. The movement of air is called wind. Try this. Fold a paper into two same sized rolls. Keep both the paper rolls on one side of a table. You and your friend should select one roll each. Without touching the roll of the paper or the table, what can be done to move the paper rolls to the other end of the table? Yes, you can blow on it. The boy is seen to be blowing with his mouth, and the girl is using a book to roll the paper with the help of wind created by moving it to and fro. See who moves the paper roll first to the other end of the table. The girl is able to move the paper roll faster. What could be the reason of the delay in making the rolls reach the other end of the table? The, the wind that is blowing is the reason. The speed of the wind, the force of the wind matters here. What can we do to move the rolls to the other end of the table with a greater speed? You will have to blow harder. Can a bottle filled with water be moved to the other end of the table in this manner? No. Can we use the same method that you tried for moving the paper rolls? No, definitely not, because the water bottle will be heavier. So let's have a look at a geographical explanation for this. We have learned that the air pressure is not uniform across the Earth's surface. In the previous chapter, you learned about air pressure. Air moves from high pressure areas towards low pressure areas in a horizontal manner. Winds are generated due to this movement. The extent of the difference in the air pressure affects the velocity of the wind. Means, if there is difference in air pressure in a particular area, suppose there is high pressure and simultaneously in other close by there is low pressure area, winds will blow from high pressure towards the low pressure. If there is less difference in the pressure, winds blow with less velocity. And wherever there will be a big difference, the winds blow with greater velocities if the pressure difference is greater. Wind speed also varies. Wind velocity is measured in the units of knots or kilometers per hour. So you have to remember that winds blow from high pressure towards the low pressure. When we consider the earth as a whole, we find the direction of the winds is influenced by the rotation of the earth. Now in red color arrows, you will see the direction of the winds are marked on planet Earth. See the figure carefully. In the northern hemisphere, winds get deflected towards the right of the original direction. So look at the arrows in red in the northern hemisphere above the equator. See 30 to 60 the red color arrow in northern hemisphere. It is showing the original direction of the wind. But the blue arrow is showing deflection towards the right in north. This is because of the rotation of the earth. Winds are deflected. So the blue color arrow marks the change direction because of rotation of the earth. That is, in the northern hemisphere, winds get deflected towards the right. Between 0 and 30 if you invert the figure, you will see the arrow is pointing towards the equator and the winds are deflected towards the right. So in the northern hemisphere, no matter where the arrow points out, the winds are deflected towards the right. And in the southern hemisphere, they get deflected towards the left of the original direction. See the figure once again. This direction has been shown by curved arrows in the figure in blue. The rotation from west to east causes this change in the direction of the winds. So in the south, if you see below the equator, just below the equator 0 to 30 degree, we have the arrow pointing towards the equator. But the change in direction of the winds due to the rotation of the earth shows the blue color arrow deflecting towards the left. That means the winds are deflected towards the left in the southern hemisphere. They are deflected towards the left of their original direction. See 30 to 60 degree. The winds in the southern hemisphere are marked with red arrow pointing towards the pole. But if you invert and see the direction, you will be able to understand that the winds are deflected towards the left. So no matter where the winds blow, towards the equator or towards the poles, they get deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. Alright, this is due to the rotation of the earth. Winds are known by the direction from which they blow. For example, westerlies are winds that blow from the west, hence they get their name westerlies. The direction of blowing, the duration, the regions covered, and the condition of the air determine the following wind types. So let's study the wind types now. The types of winds are planetary winds, local winds, and seasonal winds. So let us consider planetary winds first. Planetary winds. These winds blow all round the year. Alright, the planetary winds are called by this name because they occupy an extensive area on the planet Earth. You can see the arrows showing the planetary winds all over the planet Earth. They blow throughout the year and they cover an extensive area on the planet Earth. Hence, they are called as planetary winds. For example, the planetary winds are the easterlies, the westerlies, and the polar winds. So, the planetary winds are subcategorized as easterlies, westerlies, and polar winds. The names are given as per the direction in which they blow. So, let's start with the easterlies. In both the hemispheres, the winds blow from the high pressure area between 25 degree and 35 degree latitudes, okay, to the equatorial low pressure belt. See figure 5.3. Due to the rotation of the earth, the original direction changes. So, you can see the mid-latitudinal high pressure belt between 25 to 35 degree in both the hemispheres. And from there you will see the winds are blowing towards the equator. So we are studying about the easterlies, as you can see in the figure. The easterlies are seen blowing towards the equator from mid-latitudinal high pressure belt towards equatorial low pressure belt. We have the easterlies. Now let's study about the direction. In the northern hemisphere, they blow from the northeast. You can see the direction from northeast to the southwest. That means they blow from northeast. They originate from east. That's why the easterlies to the southwest. Whereas in southern hemisphere, they blow from the southeast. Again, they originate from east only in the southern hemisphere. So southeast to northwest. These winds coming from both the sides converged near the equatorial low pressure belt. That is the equatorial calm belt. These winds are known as the easterlies. So pay careful attention to the direction. They blow from where? From the northeast to southwest in northern hemisphere. And in the southern hemisphere they blow from southeast to northwest. Alright, now let's look at the direction. They generally blow from east to west. Hence their name easterlies. Now let's learn about westerlies. In both the hemispheres, winds blow from the mid-latitudinal high pressure belt, again the mid-latitudinal high pressure belt you have to look, to the subpolar low pressure belt. Now they are moving towards subpolar low pressure belt situated near 60-degree parallel. See the figure 5.3. So now in the previous what you learnt about the previous winds, easterlies, the winds blow from mid-latitudinal high pressure belt towards the equator. But now from mid-latitudinal high pressure belt, they are blowing towards the subpolar low pressure belt. And these make up our westerlies. Now let's learn about the direction. Their original direction changes due to the rotation of the earth. In the southern hemisphere, these winds blow from the northwest to the southeast. So you can see here that in the southern hemisphere, look in the south. In the southern hemisphere, these winds are blowing from where? Northwest, from the west direction, hence the name westerlies, to the southeast. And in the northern hemisphere, now come up and look in the northern hemisphere. In the northern hemisphere, they blow from southwest. So again from west, hence the name westerlies. Southwest to the northeast. These winds are called as westerlies. In both the hemispheres, winds which blow from west. Okay, and they blow from west towards the east. In both the hemispheres, these winds blow from west to east and hence they are called as westerlies. Now let's learn about polar winds. In both the hemispheres again, winds blowing from the polar high pressure belt. Look at the top, polar high pressure belt, and the bottom in both the hemispheres. To the subpolar low pressure belt, which is between 55 to 65 degree, we have subpolar low pressure belt. These are known as polar winds. Generally, they blow from east to west. Okay, the direction of these winds is from east to west. And this way, we have completed learning about planetary winds. So, planetary winds are of three types. Which are they? Easterlies, which blow from east to west, westerlies, which blow from west to east, and polar winds, which also blow from east to west. Alright, now do you know winds in the southern hemisphere blow with great velocities? The southern hemisphere is mostly occupied by oceans. In this hemisphere, the obstacle caused by the relief of the land surface is almost absent. As there is no obstacle, winds blow with greater velocities in the southern hemisphere as compared to the northern hemisphere. So in the southern hemisphere, winds blow with great velocities. Great velocities means great force, great speed. Why? Because there is no obstacle. Mostly the area is covered by water bodies. No obstacles. Whereas in northern hemisphere, mostly we see continents and land. So let's see the characteristics in the southern hemisphere. Beyond 40 degrees south, winds blow with tremendous velocities. These winds are called roaring 40s. Around 50 degrees south, winds are stormy. Hence, they are called furious 50s. The stormy winds around 60 degrees south make tremendous noise and hence they are called screeching 60s. Why are such winds not found in the northern hemisphere at 40 degree, 50 degree and 60 degree parallels? Yes, because as mentioned earlier, there is obstacle because of land surface occupies majority area in the northern hemisphere as compared to southern hemisphere. The southern hemisphere less obstacle because of vast area is covered by water bodies. Alright. Now we come to the next part, that is the local wind. What are local winds? The winds that blow over a short period of time originate in specific regions and blow over a limited area are called local winds. They affect the climate of the region. Okay? Wherever they blow, they affect the climate of that region, particular region. These winds are known by different local names in different regions where they blow. So let's have a look at local winds. To begin with, local winds can be divided as following: valley and mountain winds, land and sea breeze. Alright, so let's have a look at valley breeze. This figure is there in your textbook, page 23. You can also note down the characteristics in the empty box in your textbook below it. You can compare with the characteristics of mountain breeze and write down. So first let's learn what are valley breeze. Valley and mountain winds are local winds. During daytime, air on the mountain tops get heated faster. Now remember, you have to understand the difference between temperature and air pressure. Wherever the temperature is high, air pressure is always low. So now mountain tops are getting heated faster, means temperature is high. So what will be the air pressure there? Low. Yes. So the air on the mountain tops get heated faster and the air in the valley is not very hot. Means the air temperature in the valley is low. Since the air temperature in the valley is low, not very hot means low temperature, the air pressure will be high. So high air pressure in the valley region than on the mountain top. So winds start blowing from high pressure towards the low pressure, that is from valley towards the mountains during daytime, and these winds are called as valley winds. Okay, so it's quite simple. During daytime, the valley is comparatively cool as compared to the mountains. And because of the cool temperature, low temperature, the pressure is high and winds blow from valley towards the mountain, which are called as valley winds. At night, mountain tops cool down faster, means the temperature is low on mountains. If temperature is low on mountains, the air in the valley is comparatively warmer. Now, since the temperature is low on mountains, air pressure will be high. Correct. So winds will blow at night from mountain towards the valley, from high pressure towards low pressure, and hence they are called as mountain winds. So during the night we have mountain winds and during the day we have valley winds. So this is how mountain winds and valley winds blow. The region up to 5 degrees north and 5 degrees south of the equator remains calm for most of the year and winds do not blow in this region. It is called the equatorial calm zone or doldrums. In the area near the Tropic of Cancer and Tropic of Capricorn, that is between 25 degree and 35 degree north and south, there exists a high pressure belt. This is also a calm belt. This belt is known as horse latitudes. So this is for your information. So you have studied about mountain winds and valley winds. Now let us learn about land and sea breeze. So we will compare just like mountain and valley, how we compared during day and night time. Same here. During the day, the land in the coastal areas gets heated faster than the sea water. The land is hot, means temperature is high on land. So air pressure will be low. Whereas the sea water, the temperature is low, air pressure will be high. So can you tell me now how will the air pressure be or the winds be from where to where? From high to low. Yes. So can you name it? Where is the high pressure formed? Yes, on the sea. Since the high pressure is formed at the sea level, we see the winds blow during the day from sea towards the land, from high towards the low. Sea is having comparatively low temperature, so high pressure. High to low, the winds will start blowing during the day, and that's why we can say that sea breezes move during daytime from sea to land, high to low always. Okay, so you have this figure 5.5a sea breeze in your textbook on page 24, which clearly shows that during daytime the sun is there, that means it's daytime. The sea is comparatively cool. Cooler sea breeze blow to the land from high pressure towards the low. Okay. Now let us study about the land breeze. During night time, the air pressure is higher on land during night time. At the same time, the air pressure on the sea is low. You can see at night time the temperature is low. Land cools down faster compared to the sea. Okay. So, hence the land breeze blows from land towards the sea during the night. So, you just have to keep in mind wherever the temperature is low, there will be high pressure and winds will blow from that high pressure area towards the low pressure area. So, what have you learnt now? That during the night we see that the air pressure on land is high because of low temperature, and so winds blow from high pressure towards the low pressure, that is from land towards the sea, and that's why they are called as land breezes. Cool land breeze blows towards the sea at night. So which winds blow during the day? During the day we have valley breeze and sea breeze, and during the night we have mountain breeze and land breeze. All right. So these are about local winds: land breeze, sea breeze. Besides these, there are other local winds blowing in different regions due to specific conditions. Okay, these are also called local winds. For example, Phone, Chinook, Bora and Lu. You can see the table on page 26 of your textbook. It explains the characteristics and areas of influence as well as nature of the wind of this particular winds. Alright. Now let us move to the next part, that is seasonal winds. Winds that blow in particular seasons are called seasonal winds. Alright. Seasonal winds are generated due to the uneven heating of land and water in different seasons. During summers, monsoon winds blow from the sea to the land, and in winter they blow from the land to the sea. The monsoon winds change their direction in summer and winter. Now look carefully at the figure. Southeast Asia on top left, you can see East Africa on the left, and North Australia towards the bottom right are the regions where the pronounced effect of these winds are felt. Okay, which winds? The monsoon winds. The influence of monsoon winds is seen in the summer and winter seasons in the Indian subcontinents. Due to these winds, the Indian subcontinent experiences monsoon and retreating monsoon season apart from summer and winter. So the monsoon winds that blow over India are the best examples of seasonal winds that we are studying. So what are monsoon winds? Monsoon winds are in fact sea and land breezes blowing on large scale. Most of the precipitation in the Indian subcontinent is the effect of the monsoon winds. after crossing the equator. Now look carefully. After crossing the equator, what happens to these winds? We are talking about the monsoon winds. They blow from the southwest. So above the equator, equator is shown in highlighted in pink color. So above it, you can see southwest seasonal winds. Okay. So after crossing the equator, they blow from the southwest towards the Indian subcontinent during the period from June to September. They are called the southwest monsoons. They are full of moisture since they are blowing from water bodies towards the land. They contain a lot of moisture when they blow. Alright, so these are the southwest monsoon winds or seasonal winds. Whereas, now you look at the figure carefully. Above the equator, from September to December, because of the low pressure area developing near the equator, winds blow from Indian subcontinent. So you can see the direction of the arrows. Winds are blowing from Indian subcontinent towards the equator. These are called northeast monsoon winds. You can see the direction. They are coming from north and blowing towards the going towards the other direction. From northeast they are coming in, so they are called northeast monsoon winds. These are dry winds. Since they are blowing from land towards the ocean bodies, they are dry winds. Okay, so you have studied about monsoon winds here. Two types of monsoon winds, which are the southwest monsoon winds and northeast retreating monsoon winds. Okay, now let us study about the, so you can see in this picture southwest seasonal winds, that is southwest monsoon winds, and northeast retreating monsoon, that is northeast retreating monsoon winds. Okay, now we are going to study about an interesting topic, that is cyclones. These two are affected by high pressure and low pressure. So, what are cyclones? Cyclonic conditions are created when a low pressure area, you can see the low pressure inside in the figure 5.7. When a low pressure area is surrounded by high pressure areas. In these conditions, winds start blowing from the high pressure towards the low pressure area. So you can see in the center low pressure area is there and the surrounding high pressure area is created. So winds start blowing from surrounding high pressure towards the interior low pressure areas. So this is how a cyclone occurs. Now let's learn about the direction. Due to the rotation of the earth, the cyclonic winds in the northern hemisphere move in an anti-clockwise direction. Look at the red arrows. Anti-clockwise direction in the northern hemisphere. Whereas they move in a clockwise direction in the southern hemisphere. So look at the arrows showing the clockwise direction in the southern hemisphere. Now what happens during a cyclone? During a cyclone, the sky is cloudy. So you can see the cloudy sky here. Winds blow with a very high velocity. So you will see a tremendous energy, wind energy is created here, and winds blow with great speed, high velocity. Okay, and at the same time it rains heavily. So these types of cyclones can be destructive. The area affected by these cyclones is limited. The duration, velocities, direction and place of origin of these winds is unpredictable. You cannot predict the duration, how long it will last, which area it will come, where will it originate, where will it go. So all this is very unpredictable. You cannot determine it beforehand. It's very unpredictable. Figure 5.8 shows us a cyclonic storm. So now let us learn about what are cyclonic storms. Cyclones occurring in the western part of the Pacific Ocean along the coast of Japan, China, Philippines, etc. are known as typhoons. Okay, these storms arise in the months between June and October. Okay, so you can see the typhoons are developed in such areas. Due to high velocity winds and heavy rains, these prove to be destructive. Okay, now on weather maps, the center of a cyclone is represented by the letter L. A cyclone system moves from one place to another. So always a cyclone is determined by the letter L in the center to show that that is a movement of cyclone. Now the cyclones in the Caribbean Sea are known as hurricanes. These are also destructive in nature. During these storms, the minimum velocity of the wind is 60 kilometers per hour. Cyclones also originate in the temperate zone, but they are not so powerful and hence they are not destructive. Alright, now let's learn about anticyclones. Alright, under specific atmospheric conditions, the air pressure in a particular region increases and the pressure in the surrounding area remains low. Means in the center now we have high pressure, whereas in cyclones we had low pressure in the center and air pressure from surrounding areas came inside the low pressure, causing cyclones. Anticyclones is just opposite. In center we have high pressure and surrounding areas is low pressure. So what will happen? Yes, in this situation, winds blow from the center towards the surrounding areas in a circular manner. So you can see the arrows here. Winds are blowing from center towards the surrounding low pressure. In the center, we have high pressure. They blow in an anti-clockwise direction. Okay, where in the northern hemisphere. So let's have a look in there. In the northern hemisphere, the anticyclones blow in anti-clockwise direction. So you see in the northern hemisphere the anticyclones move in a clockwise direction. In the northern hemisphere anticyclones move in a clockwise direction, and in southern hemisphere the anticyclones move in a anti-clockwise direction. Okay, now during an anticyclone, the skies are quite clear. So you see clear sky. Then winds blow with lesser velocities and the weather is pleasant. So you see pleasant weather when anticyclone is observed. Anticyclone generally last for a few days or a week. Such anticyclones originate in temperate zones. Okay. On weather map, the center of an anticyclone is represented by the letter H because high pressure is there in the center in an anticyclone, whereas low pressure in a cyclone. So letter L for cyclone, and for anticyclone, since high pressure is there in the center, we have letter H for high pressure. Anticyclones are vividly experienced in high pressure belts. Winds in these regions are always moving out and hence the rainfall in such areas is quite low. From high pressure winds are blowing out. So there in such areas the rainfall is low. Do you know? Naming the cyclones. Cyclones occurring in different parts of the world are assigned different names. A list of names is prepared for each of the oceans or its part. Names in the list are suggested by the countries in the region of that ocean. If the wind speed in the storm exceeds 33 knots, that is 60 kilometers per hour, the cyclone is assigned a name. Names make it easier for us to remember a particular storm. Alright, so you can do an activity here using the internet. You can obtain information or photos and maps of the recent cyclone that arrived at India's eastern coast. write the social and economic effects of that cyclone. Okay, so it's quite interesting. You will get a lot of information, a lot of videos about cyclones and hurricanes and typhoons on Google. So you just have to search for those videos. All right. So what did you learn in this chapter? You learned about types of winds, the three types: planetary winds, seasonal winds, also called monsoon winds, and local winds. Planetary winds are further subcategorized as easterlies, westerlies, and polar winds. Seasonal winds are of two types, that is southwest monsoon winds and northeast monsoon winds. Local winds are further categorized as cyclonic winds, anticyclonic winds, valley breeze and mountain breeze, land breeze and sea breeze. So this way we have completed our chapter on winds. So students, read the textbook for a better understanding. Do watch videos related to this chapter and gain more information and enhance your knowledge. So keep safe, keep learning, and thank you.